Hello friends, welcome to another video of Zeta Axis, and today we are going to see chapter 6 Landforms and their Evolution part 2 of 11th standard NCERT Fundamentals of Physical Geography. This video lecture is part of the lecture series in which we are covering all the chapters of NCERT of each standard starting with 11th standard. We have already discussed in the previous video about landforms and their evolutions chapter. We went through the process of weathering, how these landforms are created. Then we saw the running water, the two types of running water which mainly causes this erosion, overland flow and streams. And then we also went into the different types of stages these rivers flow through different types of landforms like the canyons and the gorges which are formed by them, alluvial fans, delta. So we have seen all this in the previous video and we went till the groundwater. In this video we will start with groundwater. So we will see what are the landforms created by this groundwater. So let's start. So here the interest is not on groundwater as a resource. Remember, here we are not studying it as a resource like how much water is available or whether the groundwater level has depleted, but here it is our focus is on the work of the groundwater in the erosion of land masses and evolution of landforms. So basically we are going to study the different landforms which are created by this groundwater erosion. Remember, the groundwater is within below the surface of the earth, and because of its presence there, it forms certain landforms. So that is what we are going to see over here. The surface water percolates well when the rocks are permeable, thinly bedded and highly jointed. So not all the rocks, they allow water to percolate or go downwards. If there are joints like you can see over here, these are the joints in these rocks, or if there are gaps or if the rock is permeable, that is, it allows, there are pores which are connected. So if the pores of a rocks are connected, then it is called a permeable rock. So such type of rocks, what they do, they allow the water to move downwards. The water can enter this type of rocks and create different types of landforms. So here you can see that there are different joints over here, different cracks are there in this rock. So it is these cracks through which the water from the surface will enter the ground and start the process of erosion. After vertically going down to some depth, the water under the ground flows horizontally through the bedding planes. So here you can see that this water, it has entered from the surface and then it has reached a certain level where there are rocks are less eroded, or there is some space, some horizontal bedding is there where the rock can flow horizontally. So here you can see there is another layer of rock which is not resistant, which is more resistant than these rocks. So the water will flow horizontally over this layer. So the water moves vertically downwards and then it finds a bedding plane where it will flow horizontally through the bedding planes, joints, or through the material themselves. So it can flow horizontally over the bedding planes, joints. If the joints are horizontal, so you can see these are the cracks. If these cracks are horizontal, then it can flow horizontally in the ground or beneath the surface, or through the materials themselves. So here you can see that they are moving through the rocks. Here they are moving over another rock. So beneath the earth there would be certain regions where the water will collect and they will move horizontally. It is this downward and horizontal movement of water which causes the rocks to erode. It is basically this process where the water is moving downwards as well as the water is moving horizontally within the rock surfaces. It creates this erosion. Physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms. The physical or mechanical removal, remember physical means weathering, like the weathering which was created by physical forces, like there was this frost action, or there was this abrasion where there were debris within the running water and it would collide with the river bed or river floor, and then it will cause erosion. So such type of erosions do not occur in the groundwater. So all the physical or mechanical removal of materials is not done by the groundwater because they do not flow with that much velocity, nor do they carry that much debris with them. That is why the physical or mechanical process of weathering or erosion is not supported by groundwater. That is why the results of the work of groundwater cannot be seen in all type of rocks, and that is why you cannot see the groundwater erosion or groundwater landforms in each type of rock. There are only certain types of rock which are soluble. Remember, physical or mechanical removal of materials is not possible. Only chemical weathering, that is chemical erosion, is possible, where there is this chemical reaction with the rock. So if the rocks has certain elements which react with water and get dissolved, like if there are certain salts, so it is by this process that groundwater creates landforms. So remember, there is no physical or mechanical removal of materials, only chemical, that is only by the process of solution and precipitation. So that is why the results of the groundwater cannot be seen in all type of rocks. Only the rocks which have certain salts which dissolve in water, there you will see the effect of groundwater. But in rocks like limestone, limestone is one of the most significant example where you will see the underwater or groundwater reacting with the rocks and creating the landforms. So below the surface landforms are most widely seen in limestone rocks. Then you have dolomites rich in calcium carbonate. So calcium carbonate basically dissolves or reacts with the water. So if the rock in a region has large amount of calcium carbonate, it will react with water and it will be removed from there. And this process creates certain types of landforms which we will see today. The surface water as well as groundwater through the chemical process of solution and precipitation, deposition. So see, there is only chemical process of erosion and deposition occurring over here. And in the chemical process, there are two processes, specifically solution and precipitation. So we know what is solution. Here we have considered that there is this salt, NaCl, or common salt is there, and if you dissolve it in water, then it dissolves, the salt disappears. Now if the water flows away, the salt will also be removed. So this is the solution action. What is precipitation? So if you increase the concentration of like salt within the water or certain other elements, so there will come a point that they will try to precipitate, they will start to precipitate in the form and collect. Even if there are two elements which are dissolved in the water and they react with each other, even then they will precipitate and get collected over a region. So this is precipitation and this is solution. This is the method of erosion, this is the method of deposition. So that is why they are saying that surface water as well as groundwater through the chemical process, remember chemical process only, no physical process, of solution and precipitation deposition develop varieties of landforms. These two processes of solution and precipitation are active in limestone or dolomites, occurring either exclusively or interbedded with other rocks. So if there is a region where all the surface rocks are made of limestones or dolomite, there also you will see that if there are certain regions where these limestones and dolomites are embedded, means there are other rocks surrounding it, and there is certain specific regions where you find limestone and dolomites. For example, suppose this is different layers of rocks, and only here you have this much section of limestone. So this limestone is embedded in other rocks. So even here you will see that this kind of the groundwater will react with the limestone or dolomite over here and it will create landform. So groundwater erosion will also be visible in these cases where there is limestone and dolomite with other type of rocks. Any limestone or dolomite region showing typical landforms produced by action of groundwater through the process of solution and deposition is called karst topography. So there is a very specific name for the groundwater landforms created in the limestone, and it is called karst topography, after the typical topography developed in limestone rocks of a region. So there is a region in Balkan area where it was first observed, and it is from that we have developed this name. So it is widely seen in Adriatic Sea. In fact, most of the Mediterranean coast, you will see there is large amount of limestones, and that is why these kind of topography are widely seen in those regions, specifically in the European Mediterranean coastal regions. In fact, even in UK or even in England, there are coasts which are made of limestones, and such type of topographies are seen over there. The karst topography is characterized by also characterized by erosional and depositional landforms. So remember, this topography has both erosional and depositional landforms. We can see that erosion is caused by solution and deposition is caused by precipitation. Here there are elements in the solution which react to form certain chemical elements which are insoluble in water, and they collect over a region. Let's start with, these are the different types of landforms which are formed, which we will discuss today: pools, sinkholes, lapis, limestone pavement, and caves. And there are certain others. So these are erosional landforms. And in the next section we will see depositional landforms. The next section also we will cover in this video. So pool, sinkholes, lapis, and limestone pavements. Small to medium size, round to sub-rounded shallow depressions are called shallow holes. So the first is shallow holes, and what it is a small to medium sized round to sub-rounded shallow depressions. So if we see this region and if we consider it as a region which is made of this limestone, so limestone is basically soluble in water, and if there is heavy rain in this region, or if there are certain streams, so what you will see that over the time this type of holes are seen on the surface of this region. So these are small holes. If they are small, so small to medium sized round to sub-rounded shallow depressions are called swallow holes. So these are swallow holes. Why? Because they suddenly appear on the ground, and sometimes their bottom goes very deep. So anything that falls in this disappears. So that is why they are called swallow holes, formed on the surface of limestone through solution. So the process is solution. Here the calcium carbonate in the limestone rocks are dissolved by the groundwater, creating this type of hole. Sinkholes are very common in limestone karst areas. The sinkhole is an opening more or less circular at the top and funnel shaped towards the bottom. So here is another landform, that is a sinkhole. So if we continue with this animation, you will see that these holes, they would increase over time. There would be certain regions where you will see that whole larger area has been eroded. There is a very wide region which has been removed. Here you can see that this hole has become very large, and the stream which was flowing through here, now instead of flowing through here, the stream water, it falls in that hole and it disappears. So that is why you can call it as sinkhole. These sinkholes are generally funnel shaped, so it will have a wider bottom, and it will have a wider opening at the top, and the bottom would be narrow, something like this. It would be something narrow like this, and they could be connected to an underground cave like area. So this is how sinkholes are there. A sinkhole is an opening more or less circular at the top and funnel shaped towards the bottom, with sizes varying in area from few square meter to hectare. So size can vary, but they have more depth than the swallow holes, and these sinkholes are generally funnel shaped. Here we can see the examples. This you can see as a swallow hole. So here you will see that there is opening on the surface which connects to a cave. If this opening becomes bigger, it becomes sinkhole. Here you can see an example of sinkhole. Now here there is water in this sinkhole. Here you can see that there is no water over here, and you can clearly see the funnel shape. So the opening is circular while it tapers near the bottom, and this can also be very deep. It could also be connected to some caves way below the ground. So that is why it is called sinkhole. And sizes vary in area, so size can vary, with depth also varies from less than half a meter So the depth could be less than half a meter to 30 meters or more. So you can see the depth could be as low as half a meter to 30 meters. Some of these form solely through solution action. So they are called solution sinks. What is solution action? So basically, if there is abundant amount of water in the region, then the calcium carbonate in the rocks will be dissolved. So the sinkholes which are created because of this removal of calcium carbonate or the groundwater absorbing the elements in the rocks, then they are called solution sinks. However, sometimes what happens that others might start as a solution form. So there may be other type which start by the action of water solution. But if the bottom of a sinkhole forms the roof of a void or cave underground, it might collapse, leaving a large hole opening into a cave or a void below, and it is called collapse sinks. So here you can see an example. Suppose that there is this is another type. Here you can see that there is this cave and there is this solution going on. So over the time, what will happen that this could collapse, and when it collapses, you can see a sinkhole is created. So this kind of sinkholes which are created by collapse of the rock layers in middle, there is a cave below this sinking region, and there is this intermediate rocks which get collapse, and because of that it is called a collapsing. So there are two types of mainly sinks. There are also other types, but here you have to focus on two: solution sinks and collapse sinks. Now here you can see the difference. So collapse sinks, you can see that it started like this, but if there is this cave, then the overlying area may collapse, creating a very wide channel which connects to this cave. So this is collapsing, this is solution sink. Here this depression is basically created by the action of water, by the chemical reaction between water and the rocks over here. Here it is because of physical collapse of the rocks in between the cave and the surface. Quite often sinkholes are covered up with soil, mantle, and appear as shallow water pools. Anybody stepping over such pools would go down, like it happens in quicksands in deserts. So many times what happens there, like you can see over here, that the sinkholes may be covered with soil, and it might not appear that it is a very deep sinkhole, but when you step into it, you can fall into it. It could be very deep. So the looks could be misleading, even though it looks that the depth is not so much. If anyone steps in it, it can be very deep. Then the term doline. So here is another landform, that is doline. Is sometimes used to refer to the collapse sinks. So sometimes this term is used to refer to the collapse sinks. Here we can see the landforms and their example. So here we can see that this is the doline, which is a collapsed sink. That is, the roof has fallen down onto the cave below. So a sinkhole which is created by that is called collapse sink or doline. There is another word for the same sink. Solution sinks are more common. So solution sinks are more common than the collapse sinks. Remember, even the collapse sinks, they also generally start as solution sinks, but because of the collapse of the roof of the caves, they are formed. So even the collapse sinks, they start as solution sinks, and solution sinks are the most common type of sinks which are observed. Quite often the surface runoff simply goes down, swallow and sinkholes and flow as an underground stream and re-emerge at a distance downstream through a cave opening. So many times what happens, like you can see over here, there is this stream, and this stream, it will fall in this sinkhole and it will flow inside, it will reach a layer, and then it will flow on that layer, and then it will re-emerge someplace away. So it re-emerges from a cave. So because it disappears here, so it is called a disappearing stream or stream and re-emerge at distance downstream through a cave opening. So they will disappear into this sinkhole, they will flow through the different layers, and at certain distant place they will come out of this landform from the caves. When sinkholes and dolines join together because of slumping of materials along their margins or due to roof collapse of caves, long, narrow or wide trenches appear called valley sinks or uvalas. So here is an example of this. So basically what happens that when these different sinkholes, they join together, they combine. So if there are different sinkholes, as you can see over here, there is another one over here, another one over here, and all of them, they combine either due to increased amount of solution or the roof collapse, then the size will increase and they will appear like a valley. As you can see, here is a valley like structure. So these type of valleys are called valley sinks or uvalas. Gradually, most of the surface of the limestone is eaten away by these pits and trenches, leaving it extremely irregular with a maze of points, grooves and ridges or lapis. So if there is a region where their surface rocks are made of this limestone, so because of the solution action, what you will see that over the time, a lot of regions there the limestone will be completely dissolved in water and removed away, and you will see this type of structure in that place. So surface of the limestone is eaten away by these pits and trenches. So basically these sinkholes which are formed, they will absorb and they will remove all the limestone from the surface, leaving behind this type of structure where you will see extremely irregular with a maze of points, grooves and ridges or lapis. So here you can see these are the ridges. They could be very tall, they could be very small, but these are the ridges and these are the grooves. If there is isolated region, then you can call it as a point. So you can see there are these trenches and these ridges. The ridges are also called lapis. So basically, if there on the surface there is this limestone rocks and a very long-term erosion goes on, then you will see this type of landform in that region. Specifically, these ridges or lapis form due to differential solution activity along parallel to subparallel joints. The lapi field may eventually turn into somewhat smooth limestone pavements. So you can see that this is a limestone rock and there are different joints. Remember, what are the joints? So joints are basically fractures in the rock along which there is no movement in the rock. So if this is a joint and no relative movement has occurred between the two layers, adjoining layers, then it is called a joint. And if relative layers have moved with respect to each other, then it is called a fault line. So here these are the joints you can see. Now water, it will seep into this rock through these joints, and the limestones which are closer to these joints, they will be dissolved first. So you can see this type of structure will be formed. Here you can clearly see that there was this joint. You can see that this joint is there and this joint is there. The water seeps through this joint and it will dissolve the limestone in the adjoining region. So that is why it is saying differential solution activity along parallel to subparallel joints. So differential solution means at one place there is a higher amount of solution activity going on, at another place there is less rate of solution going on. So differential solution activity along parallel to subparallel joints. So these are the joints. You can see that they are like parallel. If some joint is, you can see that these joints are subparallel. They are not perfectly parallel, but because the water seeps through these joints, the rate of solution will be higher at these joints compared to in the middle of the rocks. That is why you will see this type of structure formed on the surface of the earth over a long time. So this type of structure is called limestone pavements, and here you can see a real image where this type of landform is formed. So you can see these are the limestone rocks. This whole region was covered with limestone rocks, but because of prolonged erosion or prolonged activity of water, what happened that the limestone was dissolved away from many places, And even here you can see that the process of solution is still going on. That is why you see that within these joints of different rocks, the water has entered and it has dissolved the rocks over here. And over the time, even in certain 100 years or so on, these all rocks will also be removed and dissolved away. Now another important landscape is caves. In areas where there are alternating beds of rocks, shales, sandstone, quartzites with limestones or dolomites in between, or in areas where limestones are dense, massive and occurring as thick beds, cave formation is prominent. So cave formation is prominent in both the areas where the whole area is made of limestones. As you can see over here, this whole region is made of limestones. There could be another region where the top layer is made of one rock, then you have another layer which is made of limestones like this, and then there is another layer which is made of another hard rock. So even in this region as well as in this region, where you see that the whole area or whole upper rocks are formed of limestone, and here you can see there is another layer which is formed of another type of rock which is resistant to solution. So in both the cases you will see formation of caves like this. So these are caves, these are example of caves, and they are peculiar to the groundwater landscape in the limestone regions. Water percolates down either through the materials or through cracks and joints and moves horizontally along bedding planes. So we've already seen that it moves through these joints, which we can see over here. There is this bedding plane. You can see that this is one rock, this is another rock, so this would be the bedding plane. It could move horizontally in the joints as well as on the bedding plane. There can be maze of caves at different elevations depending upon the limestone beds and intervening rocks. So you can see that caves are formed at different levels, and this also depends on the structure or layering of the rock. So suppose if there is another hard rock over here, then the water which percolates, it will be collected over here and it will cause formation of caves in this region. So this arrangement of different types of rocks in a layer also affects the formation of caves. Caves normally have an opening through which cave streams are discharged. Caves having openings at both the ends are called tunnels. So generally caves will have an opening through which the water which has entered from top, it flows outwards. So generally there is always an opening on one side, but if there is opening on both the sides, for example here you can see that if the water moves out from here as well as the water moves out from here, both the sides, then this could be called a tunnel. The tunnel is like it has opening on both sides, while a cave has opening on only one side. Here again you can see a different example of this type of topography, where you can see that there are different bedding planes and water has moved inside these rocks and they have caused erosion, and caves have been created at different levels. And here also you can see that the stream, it falls into it, it disappears, and then it would come out either from here or it could come out from another place like here. So the stream will appear at another place through a cave, and if both the sides of the cave are open, then it is called a tunnel. So now let's see depositional landforms. So far we have seen the erosional landforms, where the material or the elements were removed from the rocks. Now we will see depositional landforms, that is the landforms which are created by deposition of elements by the groundwater. And remember, this occurs by the process of precipitation. Many depositional forms developed within the limestone caves. The chief chemical in limestone is calcium carbonate. We have already seen that the limestone mainly consists of calcium carbonate, which is easily soluble in carbonated water. That is carbon dioxide absorbed in rainwater. So basically it forms this carbonic acid. If there is carbon dioxide in the water, then it will form a carbonic acid which reacts with the calcium carbonate and dissolves it. That is why presence of carbon dioxide in the water, it helps in solution of the calcium carbonate. This calcium carbonate is deposited when the water carrying it in solution evaporates or loses its carbon dioxide as it trickles over rough rock surfaces. So here you can see one example. Water is dropping over here. Now because of the very small amount of water, you can see that some elements are deposited over here, so the length is increasing, and as it moves over here, now because of very small droplets, water will also evaporate from here, so it leaves behind the calcium carbonate elements in this region. So you can see that because of this, the deposition occurs here on the upper part as well as on the lower part where the drops are falling. So whatever elements are there dissolved in this water, it will be collected at the top as well as at the bottom. And this is true for a whole bunch of elements, not only calcium carbonate, but there are different types of elements which show this type of property. So because of this, we see large number of landforms in the caves. So let's start with the most important ones. So first is stalactites, and then stalagmites, and then pillars. So all these three are related basically. So the stalactites hang as icicles of different diameters. So here you can see in this image, these are the stalactites which are hanging from the top. So as we saw that water, it drops slowly from this region, so it will deposit some elements on this, and over the time what will happen, because of this deposition which continues for hundreds of years, you will see that they will get elongated. So here you can see these are smaller, but for hundreds of years of deposition this will become longer, like these are there. So normally they are broad at the bases and taper towards the free end, showing up in a variety of forms. You can see that they are broader over here and they will taper downwards. Now we have stalagmites, rise up from the floor of the caves. In fact, stalagmites form due to dripping water from the surface or through the thin pipe of the stalactite immediately below it. So basically it is formed, as you have seen in the previous video, that when the water drops, it will leave some elements, it will deposit some elements over here as well as it will deposit certain elements over here. It is because of this process, you will see that water, groundwater, which drips from here, it will fall, and there also it will deposit certain elements. So that is why you will see formation of the structures both from the floor as well as from the ground. So because it is ground, you can remember that it has a G, so it comes from the ground, and it has C which indicates ceiling, so it comes from the top. So if you want to remember which one comes from the top and which one comes from the ground. Okay, so we have seen how these two are formed. Then over a prolonged time, what will happen, that because of this type of deposition, they both would eventually combine together. Here you can see one such example, that it has formed a one continuous structure. So stalagmites may take the shape of a column, a disc with either a smooth rounded bulging end or a miniature crater-like depression. The stalagmite and stalactites eventually fuse to give rise to columns and pillars. So you can see that these both, they combine together to give rise to columns and pillars of different diameters. So here we can see formation of these pillars. So here it is talking about stalagmites may take the shape of a column, a disc with either a smooth rounded bulging end or a miniature crater-like structure. So it is generally in the form of a column. It could also form a disc-like structure with either a smooth rounded bulging end or a miniature crater-like. So it could form like a crater. I think it could form like, it could get deposited like this. Means this would be the ground region, and at the top you can see like this, or there could be even a rounded shape. These can attain a rounded shape. So with this, we have completed all the landforms of groundwater erosion as well as groundwater deposition. So we will conclude this session over here, and in the next session we will see glaciers, the landforms which are formed by glacier erosion as well as glacier deposition. So thanks for watching the video. If you have liked the video, then do subscribe to the channel and share it with your friends. If you like what we are doing, then you can support us using the Paytm ID. Thank you for watching the video and watch the full series to get the understanding. And if you have any questions or any feedback, then you can give them in the comments. Thank you.